this video is going to look at writing unit tests to verify the correctness of the methods that we write in our programming. To keep things simple, I'm going to create a method. I'm going to introduce a very obvious bug in that method. It's going to be a very trivial method, and then we're going to look at how we can write tests to test it, so other code that tests the methods that we've written. To be able to test a method, it must be public. Okay, so we need to use a public keyword. We're going to focus on testing static methods today, as we've not covered classes and other things we need, but it is possible to test methods that aren't static, but for now we'll just make a static method. And my method is going to add two integers together. So I'm just going to call it add, and we'll have int a and int b. Okay, and then I'm going to write the solution with hopefully what you spot as an obvious bug. And there we go, there's our method. Now, we could obviously write code in here to test it and then run it, but if this was part of a larger program, this would be quite arduous to do. It'd be difficult to sort of create a, go into the main method and test something that sort of sits in the middle of a larger program. So what we can do is we can write tests that test it instead. So there's a little bit of setup we need to do in order to do that. It's good practice to put our tests in their own folder. Okay, so if we look at the folder structure of our project, we can see we've got our existing source code is in the com.tinyappcode package in the source folder. What I'm going to do is I'm going to right click, I'm going to go to new and directory, and I'm going to create a new directory called tests. Could use test, doesn't really matter. And then I'm going to tell IntelliJ IDEA that my tests are in that folder. To do that, I need to open the project structure settings. So I'm going to file and project structure. I need to go to modules, and you can see already we've got the source folder marked as source, but test isn't marked. But we have the option to mark that as a test. So I'm going to mark that as a test by clicking here. I'm going to click on OK. So we've now got somewhere to put our tests. Now we can actually get IntelliJ to do a lot of the setup of our testing for us. So what I'm going to do is I'm going to go into my add method, I'm going to right click, I'm going to go to generate, and I'm going to choose test. You can also do it by going to navigate and to test and choose create new test. Either of those two approaches works, and there's even a shortcut, keyboard shortcut, which is Command Shift T. I think it's Control Shift T on Windows machines. So we'll do that. We'll do it this way because it's easiest. Generate test. Now there are lots of different libraries that are available for running tests. So you can see it's selected JUnit 5, which is what we're going to work with, but there are other testing libraries. Each will have their own differences in the way they run the tests and different features. We're fine with JUnit 5, so we're going to leave it. There. We are going to need to supply a name for our testing class. So typically the default name is the name of the class we're going to test, which is our main class, followed by the word test. We don't need to specify a superclass, and it's going to keep the package the same. So we'll end up with a folder structure that mirrors the folder structure in our source folder. And then we can choose the tests or the methods that we want to test. So I'm interested in testing my my add method. There's not really much point testing the main method because it doesn't return anything. So there's limited testing we can do there, but our add method should return an integer. So I'm going to check that checkbox there and click on OK. Obviously, if we had more methods, we could choose to create tests, test methods for more than one. So I'm going to click on OK. Now the other thing that is likely to happen that most of you will see is a little button here that says fix when you run it for the first time, and that's because, in fact, let's bring that up. I'm just going to undo. I'm going to remove JUnit 5.7.0 from this project, so it will give you the same. We'll see the same thing that you would see. So if we go back here, generate test, it's going to come up and say JUnit 5 library is not found in the module. So basically the project doesn't know to include the code that gives us the JUnit 5 testing, so the library code that's been written to allow us to write unit tests. So if we click the little fix button, it will prompt us to download the library, okay, and all we need to do is just click on OK. Okay, so I'll then click on the checkbox to add a test for add and click OK. So just to reiterate, if we went back to project structure and looked at the dependencies, it's now added JUnit 5.7. It was there before because I'd run a previous test, but if you're doing it for the first time, you'll find that JUnit 5.7 isn't there until you click that fix button. Okay, so what do we have here? Well, you're now looking in the tests folder, and we can now see the same package. So the package is mirrored, and we've got a file called main test, and in it has an empty method called add. It has this annotation here that says test, and if we expand the imports, we can see we're importing org.junit.jupyter.api.test. Okay, so we've got access to that package, and we're also importing, this is a class, so the assertions class. Can we go and have a look at that, go to declaration, and you'll see in here it's a class called assertions, and it has lots of methods. The ones we're interested in are these ones that assert true, and there are other assert false, assert null, assert not null, assert equals, and we call these methods to check, to assert that things are as we would expect them to be. Okay, and because we've got this import static statement, we can actually use those methods without having to write assertions dot and then assert. So rather than having to go here and write assertions dot assert equals, okay, we don't have to worry about this prefix for the class. We can simply, let's just undo that, import, we can simply say assert, and then we can see all these methods. Assert equals, there are other ones. If we say array equals, so we can check that two arrays are the same. We can assert something as false. We can assert that lines match in a stream or a list. We can assert that things are not equal. There are an awful lot. We can assert that a method throws an exception. We can assert that something is null. We can assert that two things are the same. Yeah, so there's quite a lot of options. Now what I'm interested in is calling my add method and checking that the results we get back from it are correct. Okay, so what I might do is I might do something like this. I might say int result, I don't know, 2 + 2, and then I might call my method from my main class, which is called add. Okay, because it's a static method, I'd write main.add. Okay, and then I'll pass in, we're going to test it with 2 + 2. Okay, and then we're going to assert that the result that we would expect, so if we've added 2 to 2, we'd expect the result to be 4. So we can assert equals, and we want to check that. And the first one we put in is the expected value. So the expected value is 4, and then the actual value is this result when we've added 2 + 2. So we can say result 2 + 2. Okay, now let's run that test and see if it passes or not. So we can run all the tests in a class by clicking this play button here. We can just run an individual test by clicking the play button there. So I'm going to hit the play button there and run that test. Okay, now our test has passed. So you might think that's great, that method is correct, but obviously we put a deliberate bug in that method. So what part of the reason that I wanted to show you that we can pass a test but still have a bug is that you know, the methods are only good as the tests we write, and if our tests aren't comprehensive enough, then we're not going to get the results. You know, we're not going to be assured that our code is actually correct. So what we would maybe want to do is to write another assertion that tests with two different values inside the call to the method. Okay, so let's go ahead and do that. So let's say int result 3 + 7. Oops, 3 + 7 equals, and then we'll call main.add 3 7, and then we could assert that the expected value will be 10 and result for 3 + 7, and then we can run that test again. So let's run that. And what we'll see is that the test has failed. It tells us that we're expecting a value of 10 and that we've got an actual value of 6. Okay, we could see that in an alternate view there if we want. That can be useful if there's a lot more data being compared. And we can also, if we look at the stack trace here, we can see that it has failed at line 17. So we know that it's this assertion that has failed. So we now know that if we try and add 3 to 7 in our add method, it doesn't work. And actually we're getting a result of 6. And if we look at that, why are we getting a result of 6? Well, actually it's because we've added A to A rather than A to B. So we can go back and correct that. We can then go back and run the test again, and our test now passes, and we just get green ticks in our little output there. Now, one thing we do need to be aware of is we're likely to be writing tests in a project where we'd normally have an implementation of a main method. So what we might do is something like this. We might ask the user for 2 numbers, then we might call the add method, and then we might tell them what the result is. So we can obviously just come back and hit the play button to run the main method if we wanted to, but you also want to be aware that up here we can choose between the things that we've run before. So we can see our main method here, and we can also see that we've got access to the main test class. That one's from a previous thing that I was working on, so that doesn't exist, and that's got little X there. But you can also see that we can call the main test add test. Okay, so if you need to jump between running your main method and, for example, one of the tests, you can use this this drop down here. Okay, so that is essentially all you need to know for unit testing. The key thing to take away is that it's really easy to write tests that are not thorough enough. Okay, now this is a very trivial example, and we can actually be reasonably confident looking at this here that the result is going to be what we expect. But in some instances, the logic is going to be more complicated, and we're likely to write quite a few more assertions to check that everything is as it should be. The other thing writing tests does, it allows us, if we come up with a better way of solving a problem, or what we think is a better way of solving the problem, is to change the implementation and then check that we haven't broken anything. Okay, so again, there's a limit to the implementation that I can change here, but I might decide for whatever reason that I'm going to have the implementation as return B plus A. Okay, and if I do that, I've changed something. We can run our tests, and we can be relatively sure, if our tests pass, that we haven't broken anything in the process. Okay, so that's particularly useful once we start writing more complex code.